Welcome everybody. Our second presentation will be given by Dietrich Trautmann, who is with Thomson Reuters Lab. That will be on legal prompt engineering.
Yeah, hello everyone, thanks for coming. So yeah, the talk will be about our experiments on legal prompt engineering, where we did a case study on multilingual legal judgment prediction with large language models in zero-shot experiments. So this is the agenda of this talk. Please ask questions at the end, and let's start with the introduction. So first about myself, I work as an applied research scientist in the field of natural language processing. Currently I'm focused on legal NLP and especially working with large language models in the legal domain, solving a variety of tasks with them. And I work for Thomson Reuters Labs. It is the research division of Thomson Reuters, where we do all kinds of experiments that go later into the products themselves. So we have also a lot of stakeholders within the company, the different departments that we talk to, and then based on that either develop solutions that they ask for or even come up with our own, as we see in this example. And Thomson Reuters is probably well known for the Reuters news agency part, but there is way more than that. So one particular product that is also quite big, especially in the US, is Westlaw. This is the leading online research application for lawyers and legal professionals. And this is also a proprietary database. And there are a lot of cases. However, it's not only in the US, it's also in more than 60 countries by now. So now to the kind of core of the presentation on prompting. This is, in my opinion, a new paradigm in NLP. So it is a new way of how we use machine learning models, in this particular case, large language models. And this allows to really query those models directly. And this prompt-based learning is based on those LLMs, the abbreviation for them. And they model the probability of a sequence of tokens directly. And the prompts, they can contain questions about the sample that we give to the model. It can contain examples of input-output pairs and also whole tasks descriptions, depending on what you want to do. And the prompt kind of guides the model to generate useful output in your context. And legal prompt engineering, which is kind of new what we did here, is applying prompting to the legal domain. All right, yeah, so there are quite some points that motivates us for this work. So one of them being that at Thomson Reuters Labs, and in particular for Westlaw, there is a lot of human editorial work, so a lot of data annotation processes, and we would like to assist them with those approaches in prompting. We want to, of course, explore this emerging technology. And also the interesting application of this is to interact with this AI in natural language. So in theory, also subject matter experts, where there are a lot in our company, they can directly use those tools if we have the corresponding interfaces for them without any programming background. So they are the expert in this legal field, so they can maybe ask even more specific questions than I, for instance, could. And of course, the other interesting bit is the that we can save on cost for the model training, because what I will present here is really we use the model directly without any training that is currently most of the time applied. And the last bit is the large language models, they can solve a variety of tasks depending on the prompt that we design to query them. So that's kind of also a benefit to have one large model that can do a lot of things. For the task itself, we want to solve the legal judgment prediction, and the goal is to predict the outcome, although this is not the final outcome in a case, but rather a part of an outcome of a court case. And we give only the facts of the cases as the input data. And the the real world, the judges consider not only those facts, they also take other external information about the defendant and the court view and potentially also other information, but we exclude them. We use those academic data sets where we have only the facts of the cases. And the data sets that we looked into and that I will present here are the first one is from the European Court of Human Rights. There is the language of the text is in English, and it contains those factual paragraphs from the case description, and those cases, they are actually mapped to a list of human rights articles that were violated or not. And the other data set is this data set from the Swiss Federal Supreme Court in those three languages, so German, French, and Italian. And there is again also this binarized judgment outcome, whether this case was like approval or dismissal. The experiments that we did with on the model side, we will present here only one of them, but we actually looked into the initial, the BERT based family, I would say, where the training objective is to have this mask filling task. So we looked into prompts where we filled in the masked token. Then we have this GPT-based models where the objective is to predict the next probable token in a sequence. There we looked into GPT-J 6b model for the English data and also the multilingual GPT-XL for the German, French, and Italian texts. And we actually, in the initial experiments, looked also at the T5-based family, I would say, where we have the sequence-to-sequence mapping, where we also used T0 and multilingual T5. But I will focus in this talk only on the GPT-based models. So the really interesting bit of how this came along was that by initially thinking about this problem and how we can apply prompting there, one could simply use the text as it is to give to the model. So, for instance, I will try to visualize it here. So, for instance, we have this really large document. This is actually also a speciality of legal documents that they are really long. So we have this long document from the data set, only one, and we let it continue from the model. So then after the input, this goes to the model, and the model generates the completion, as we call it. And what we discovered there is that, for instance, in the European Court data set, there is this more or less list of facts, and the model continues with other facts. So it's not solving our task, but it kind of continues what's most probable. So that was really interesting to discover. In some other cases, it kind of continued the whole storyline of the case, which was interesting to read also, and quite coherent in my opinion. And the bit that kind of in this prompt engineering, this manual process, as I'm showing it here, was to reformulate our target task into a question. So, for instance, for this first task, we have the question of, was there a violation of any human rights articles? And we concatenate those two, the document and the question, and then let the model continue with the output. And this, again, kind of, in some of the cases, showed that it kind of is answering this question, but in other cases, it also created a second question, a third question, and so on. So this was also interesting to explore maybe alternatives to these questions, but not that often solving our task. So what we kind of did next then is to include those question and answer indicators. So now it should know, right? That okay, there is this long document, then we have the question position, and then the last token that gets into the model is this answer, and then it should map from questions to answers, right? This again improved quite a bit, but not in many cases. So we continued further with this development of the full prompt by including those options that we are interested in. So A, yes, or B, no. Again, this kind of is then the template that we know from school exams, maybe in this multiple choice setup, here only two choices, but by including them, the probability of those tokens appearing in the completion increased again. And the final bit that was like really then also in the final scores was to include this GPT-specific end of text after our long document. So this is somehow, this token works really well into separating between the document and the core of the prompt. And by including this end of text, the model is kind of more focused on like really doing this, answering this question. So this is kind of like how we develop this and are also in constant like, contact with our subject matter experts who, as I said, could probably even create even better questions. All right. Now, regarding the answers, then we really got this type of answers, like really, like for some documents, I won't show because it's also like really hard to read, a lot of text. So like, let's say abstract, then it really generates this answer A, as we wanted to do, right? The other option is, of course, having B as an answer for the cases where it did not violate anything. So the next discovery was then to the generation or the completion of the model. It is actually, there is also another parameter where we can control the length of the generated sequence. And although we are interested into having only one token as an output, it was not optimal for the model to express itself. So we, in the end, we had at 50 was the maximum sequence length that the model should generate. And then like sometimes it generated only one, but oftentimes, as we will see later, it generated longer text. So one such longer text would be the really, this is like really one of the examples that like it answers A with like a parenthesis, although we didn't have this in the prompt. And then it writes, there has been violations of article 2, 3, 4, 5, 7, 10, 11. So like, wow, that's like really cool. And the for this task that I'm showing here for predicting which articles were violated, the original paper that published this binarized task had also this as a multi-label classification. So now we have really this interesting like text here that we didn't ask explicitly, the list of violated articles. And then like another interesting discovery was then that sometimes it produced also texts like that. So like a comma and then explanation. So it's like really justifying its own answer, which again, we haven't asked it explicitly to do, but like apparently it can generate a comma, explanation, article 2. Everyone has the right really to participate in cultural life. And I looked it up. So this sentence is kind of a paraphrase of one of the articles of the human rights. However, the number is not this number. So it kind of knows that there needs to be a number, but like the factual information is not true. And another investigation that I continued doing here was to like look up the case where it generated this kind of explanation. And like, yeah, I mean, like it's also really hard for me to really find like whether this was really the article that was violated there. Then we had, again, although we constructed all of the parts of the prompt, we still got completions like that. So there was no violation of human rights articles. So like it's a little bit hard to then automatically map to our A or B outputs. And when we looked at the development data of this data sets, we saw that like for most of the cases where it was no violation, this kind of sentences appeared. So we mapped all of the non-A or B answers as B. And then that's also an interesting example of the prompt. So it generates like this whole red part is like A, yes, and then it generates a Q2. Like the next question is, what is your opinion about this incident? Please explain why you think so, not so. Please write at least one sentence. So like, it's really like, is it answering back? Like, but like it makes sense if we think about something like that as a school exam. So on the like the pre-training data that it kind of knows like if this structure appears, I need to output something like this. And that's kind of like also why it's interesting to like not limit on the one token length, but like let it maybe generate more context for itself. All right. Regarding our results for this zero-shot experiments, because the other limitation is there that we cannot fit the more than one document, even like for it was for the GPT-2 models a lower percentage because there is this context window of 2048 tokens that we can use. So 4 times the one from BERT, but it's still like not all of the documents fitted completely. However, the other thing in these data sets was that they are highly unbalanced. So for instance, for this English data from the European Court of Human Rights, 90% of the labels were that there was a violation, only about 10% that there was no violation. So it's kind of skewed. And we included, therefore, also those majority and random baseline scores, and of course the supervised scores from literature. And yeah, what should I say? Like, if you see at the numbers, they are quite low and crushed by the supervised approach. Although for the supervised ones, they are like trained with thousands or even like 10,000s of samples. And this is like really expensive. But, I think from all of the supervised scores that are shown here, those are the hierarchical BERT models. So they are really expensive to run over thousands of samples. And we are comparing this against this prompt that was also done just by inference on a CPU. All right. So the conclusion is then that like this zero-shot learning is possible to some degree. So like really, when we investigated the examples of like what the model generates, it, like a lot of cases made sense, in others not, of course. Then we have this limited explainability of the generation. I mean, we saw that like sometimes it also tries to create this explanation, but is it like really true? And like there are approaches for explainability for those kind of models. Maybe we can look at attention weights where they are activated in the text, and maybe then validate whether those like parts of the document are really the reason why it is this outcome and so on. And like, yeah, as I said, this like long legal documents are a challenge, and the presented approach is also not possible for few-shot, where we usually would concatenate at least a couple examples of input-output pairs that go into the model, which is shown that works quite well for sentiment analysis, where we have usually like single sentences and then a label, but like not so much for the legal documents. All right, so thank you very much. This would be it. Feel free to reach out to me. We are actively hiring. Thanks.
Are there any questions?
Yeah, please go ahead.
So, I mean, I have a bit of trouble like conceptualizing how this is useful, because in the end, like you get a prediction from like this AI, and it just makes up a random answer, and you get some scores that are better than the random. Which, okay, that's very cool. Like, I think the whole approach is very cool. But I wonder, like, what is in your expectation? Like, if you picked a random person out of this room and gave them exactly the same task, like, would it work worse than your model, or would it work better, or about the same?
Yeah, valid. And that's actually kind of the first point in the motivation, that like we have a lot of data annotation work going on, and oftentimes the human editors, they look through like large taxonomies and like thousands of samples, or like the labels that they can pick from. And if we can use those zero-shot approaches to generate like a set of candidates, because we can like sample from the output, then it kind of restricts, or like at least provide to human editors a set of labels, and then they still like this won't go into a product directly. Like there will be still a human evaluation happening, and either like there is no entry, but at least like that's the hope to filter the like possible labels for human editors.
Yeah, I mean, or like what would happen if you took untrained units? Like imagine you just take like very cheap crowd workers and you give them exactly the same task. Like,
yeah, there was actually a paper on like using language models as Turker. So like there is development in this area, and the thing is here, I did the experiments for this legal domain where we have really those long documents, and like there it's even more an issue. But for the general, like the sentiment analysis task and all day, it works way better because we have also the option of having few shots of input-output pairs. Yeah. But like definitely valid points. Like I agree.
I'm going to ask like a couple of questions. Feel free to answer whichever ones you want to or can.
Okay.
So you use a GPT model.
Yeah.
Did you look into like some kind of a model bias that could happen with judging these texts? Because do you know like which kind of text the GPT model was trained on? Secondly, you put in the entire text and then asked, what's the verdict?
Mm-hmm.
Have you thought about anonymizing some of the key data? Because let's say based on someone's name or nationality, a judge can decide differently on the same crime.
Yeah.
Then
wait, let me do So the first one was the data that it was trained on. Yeah, that's actually a really valid point. That to my knowledge, like this GPT-J6B was not trained on legal documents, like with a focus on legal documents. There is maybe a chance that they are in there, but they are not like it was not part of the corpus creation, as far as I know. So yeah, there is that. That's like kind of that's why I meant it. Like it maybe learns to map to what it kind of needs to, like this article, and then there should be a number and so on. But this is not necessarily a factual response. So like that's definitely true. And then like the second part was about.
Have you like checked what the results are?
Oh,
if you anonymized
yes,
some of the key data?
That's a good point. And the to be honest, I haven't checked it for the English data. This is again already filtered from this previous work who created those data sets. So we have only the facts, like it's not the full case. There's usually more text to that, so it's really just the facts. And the Swiss data, there is already like the names are anonymized. So there is like always this like first letter dot and then like 5 underscores or something like that. So it's already like the names are masked in the input data.
But like, did you try with or without masking? Like, it was very different.
Yeah, I mean, like but this would be a manual process, so we haven't done this yet. But this is definitely an interesting point of like switching. Like, maybe if it's letter A, then it's like more likely to be like fold or beat could happen. I agree. Like masking those.
And the third one is just a general question about Thomson Reuters. Like, is there an ethics board? Because this kind of research is very dangerous.
Exactly.
And if I have an AI deciding on if someone, like in future,
definitely we have like a huge department also regarding also this whole explainability part, also like model registry and data sets, kind of tracking of like what was used for which part. And what I'm showing here, this is not going into the product. So like this is really like the labs part, kind of exploring what's potentially already possible, and then of course like based on legal counseling. And as I said also with the other question, that this won't also go directly into a product. There's always still like a not only one human, like a set of humans that check the annotations themselves, and then they go again through a quality control process. So like really valid question, and we are paying attention to this.
Okay, thank you.
Yeah, thanks. Also like really great points.
Any other questions?
About prompt engineering, there is this thing happening about like kind of psychology of super big models. Like if you prompt, if you in the prompt you insert something reinforcing the confidence of the model, like you are a very good lawyer, or you are expert in lawyer, and it boosts the performance of the model. Have you tried something?
Well, as I said, we did like some experiments, and I'm showing only like one solution to this, and that's really interesting. We saw something for summarization task where you like sometimes you have just a simple prompt of like in summary, comma, or this TLDR, and then it continues, and then you can prompt like, and you are creating a summary of like a really famous writer who is like really great at blah blah blah. So it based on this prompt, there are different types of like quality of the output. That's true. Definitely. There is also like recent work with this common sense reasoning where they included let's think step by step, and then it kind of like really decomposed the task into subtasks, and based on that, reasoned on the final outcome. That's kind of also interesting development. Yeah. But to be fair, from like this study on let's think step by step, those are like super large models. Those are like GPT-3 and larger, and here it's like really this 6 billion, although like it's also large, but like not that large to those really big players. Yeah.
Last question.
How long was actually what you could input in there?
2048 tokens.
2000.
Yeah. We had also here a question, or?
If you have more questions, please.
Just one use from before. So this whole topic about bias in the data. So how are you guys tackling this? You said you have the explainability department which is looking into this one, but most of these models which you're using, I mean, we know in the meantime, that there is some bias in the data. So all of this is going further, it's not detected. So how do you go about this one if you have an answer saying yes, it has been violated? So do you treat that back and say, okay, that might be because of this bias in the...
I totally agree that this is an issue, but those examples are like really academic playgrounds. So like we do not have any outcome prediction automated way.
But
so
I mean, it gives, I mean, there's possibility to use it, and we all know that there is bias. But I mean, how you guys are tackling that, even in this environment, which is like.
That's a big issue in the whole industry, and for TR we actually have also in Zug now the department focusing on this whole model validation and usage. So like I'm not feeling confident to like really say something on that matter, because like I'm really doing this exploratory experiments, but this is definitely a huge part for the company moving forward.
Thank you very much.
Thank you.